This is the last class in electrochemistry. I mean, when it comes to theoretical part, this is the last class. And after this class, probably tomorrow, we will have a class on objective questions asked in previous competitive exams. Or if possible, I'll take live class. Otherwise, I'll record the video and post in our YouTube channel. This is a long-term program for JEE and NEET, even for state level competitive exams like KSET, EAP-SET of both Andhra and Telangana, and some other state exams also. And tell your friends who are interested to learn chemistry deeply and clearly throughout this year. And probably I will maintain the same time so that everyone can feel easy. Right. And today's class, we are going to discuss one more theoretical concept, that is fuel cells. And as well as at the end of this class, we will discuss about corrosion. First, I will start with fuel cells. What are fuel cells? So till now, we have discussed about some different types of batteries or different types of cells. Say for example, galvanic cells, those are electrochemical cells, and electrolytic cells. Now we are going to discuss about fuel cells, right? What are fuel cells? Okay, these are galvanic cells that are designed to convert the energy of combustion. So the energy of combustion, this part is important, the energy of combustion. So these are the cells which convert the energy of combustion directly into electrical energy. Okay, energy of combustion is converted into electrical energy. Such devices are called fuel cells. So just to make you understand, I'll ask one small question to you. If you take a piece of paper, if you burn it, what happens? If you burn a piece of paper, what happens? Obviously, in any burning process, some heat will be released, isn't it? So, for example, or you take some wood or some cloth or any other substance, or you take petrol, you take a diesel. If you burn these objects, what happens? Some energy will be released, some heat energy will be released, isn't it? Such type of heat energy is called energy of combustion. So energy due to combustion. Combustion means burning. If you burn something like hydrogen, methane, methanol, etc., some heat energy will be released. That heat energy is directly converted into electrical energy. Such devices are called fuel cells. These fuel cells are highly efficient, highly energy efficient, and they are very what to say, environmental friendly. They do not produce any pollutants. Like if you use petrol, diesel, all these type of fuels, they produce some carbon oxides, nitrogen oxides, right? But fuel cells do not produce any pollutants, so they are environmental friendly. So fuel cells are very good for environment. But the problem is these are little costly. These are little costly. So where do we generally use fuel cells? So fuel cells generally we use in rockets or spacecrafts. So this is a picture of Apollo spacecraft. Apollo spacecraft that is sent into space by USA, America. So here hydrogen oxygen fuel cell is used, right? This is the picture of hydrogen oxygen fuel cell. So getting the point, I think, I hope you understood the definition of fuel cell. What is fuel cell? It is a device which converts combustion energy directly into electrical energy. That's all, the simple definition, right? Next, this cell was used for providing electrical power in Apollo space program. Apollo space program. This is the Apollo satellite. That is sorry. What to say? This is rocket, or we can say Apollo spacecraft. Okay, as a Apollo spacecraft, space vehicle, we can say simply. And this cell consists of, and we'll see this arrangement. This cell consists of three compartments. See here, three compartments. One, two, three. Three compartments are there, and separated by porous carbon electrodes. These are separated by one, two, three. These three compartments are separated by these porous carbon electrodes. These electrodes acts as anode and cathode. So you can find here, you can see anode at the picture, right? So this one is anode and this one is cathode. These two are porous carbon electrodes. This is the first compartment, this is second compartment, and this one is the middle compartment. And you can see hydrogen gas can be sent into the first compartment through this inlet, and oxygen gas is sent into the fuel cell through this inlet. There are two inlets, and in between the these first and second compartments, one middle compartment is there. That middle compartment consists of water and concentrated potassium hydroxide, or we can also take sodium hydroxide or potassium hydroxide. So this middle compartment consists of a strong alkali which acts as a electrolyte. This is electrolyte. This is anode, cathode, and electrolyte. So here anode and cathodes are nothing but porous carbon rods. What is the meaning of porous? Porous means having small holes, micro holes. Okay, right. This is the arrangement. So through this inlet we send hydrogen, and through this inlet we send oxygen, and these two gases are forced to come into the middle compartment, which consists of, in the middle compartment, electrolyte is present. What is the electrolyte here? Potassium hydroxide, or the aqueous solution of potassium hydroxide, or sodium hydroxide we can take, right? Next, the cell consists of three compartments, right? Next, catalyst like finely divided platinum or palladium is incorporated into the electrodes for increasing the rate of electrode reaction. To increase the speed of the reaction, some catalysts are used. Generally, platinum or palladium catalysts are used. That's why the fuel cells are more costly. These are more costly because here the catalyst used are precious metals like platinum or palladium. They are very cost. Platinum is costlier than gold. It's more precious than gold. That's why fuel cells are more costly. So they are not available for all the purposes. Do you know in the country Japan, in cars also fuel cells are used. In bikes also fuel cells are used. So it is a country which uses fuel cells in a large quantity. So because the fuel cells are environmental friendly, they do not produce any pollutants, right? Next, we'll continue. Here, hydrogen and oxygen gases are then fed into two different compartments. As I already told you, hydrogen and oxygen gas fed means will send into the two different compartments. And here, hydrogen gas will be sent through this compartment, through this inlet, and oxygen gas is sent into the fuel cell through this inlet, and they diffuse slowly through the electrodes and react with the electrolyte. These hydrogen and oxygen gases diffuse, they spread. Diffuse means spreading, spread slowly through the electrodes, because the electrodes are porous carbon rods. No, these electrodes are nothing but porous carbon rods. They are already having small holes. Through those holes, hydrogen and oxygen gases enter into the middle compartment. What does the middle compartment consist? The middle compartment consists of electrolyte, potassium hydroxide, in the central compartment. So they undergo some chemical reaction over there. We'll see what are the reactions takes place there and all. Next, electrode reactions. At anode, The reaction is like this, and you can note down here reactions also important. 2H2, so hydrogen gas we are sending at anode, plus 4OH minus. From where these OH minus will come? OH minus will come from KOH. Potassium hydroxide is electrolyte now. KOH, K plus OH minus. So hydrogen reacts with OH minus and converted to water and releases 4 electrons. 4 electrons. This is oxidation process. See here, two twos are 4 hydrogens. 2 twos are 4 hydrogens. Here 4 OH groups. 4 OH groups. So totally 4 water molecules will be formed. And here 4 minus is there, no? 4 minus. Minus means electron. So 4 units of negative charge. So 4 electrons are coming out. This is the reaction taking place at anode. Similarly, we'll see what is the reaction happening at cathode. O2 plus 2H2O plus 4 electrons gives 4 OH minus. Note down O2. So in the from the other compartment at cathode we are sending oxygen gas. No, this oxygen gas combines with water and with 4 electrons. Here reduction takes place. So here how many oxygens and hydrogens are there total? Here 2 oxygens. Here also 2 oxygens. Total 4 oxygens. Hydrogens, 2 twos are 4 hydrogens. So 4 hydrogens, 2 plus 2, 4 oxygens. So total 4 hydrogens and 4 oxygens, as well as 4 electrons. Electrons means negative charge. So 4 OH minus, 4 oxygens, 4 hydrogens and 4 electrons. This minus means electrons. So 4 OH minus ions will be formed. So this is anodic reaction. This one is cathodic reactions. Now we'll see what is the overall reaction. Can you write overall reaction based on this? You can try. So I will give you hint. So how to write the overall reaction? See here, this side left in the first reaction, anode reaction, oxidation reaction, 4 electrons are there on the right hand side. 4 electrons on the right hand side. In the cathode side, that means in the reduction process, 4 electrons are there on the left side. Right side means here see after arrow mark, here before arrow mark. So these 4 electrons get cancelled. So 4 electrons get cancelled, right? Next, what are the other similar groups present? Here 4 water molecules are there. Here 2 water molecules are there. So we can cancel 2 water molecules from here, and out of 4 water molecules, you can cancel 2 water molecules. So 2 water molecules and 2 water molecules. That means here no water molecule is left, but here you can have 2 more water molecules, right? Now what will be the, so 4 OH minus and 4 OH minus can be cancelled. This is on left side, this is on right side. So both can be cancelled. So 4 electrons, 4 electrons, 4 OH minus, 4 OH minus, and 2 water molecules and 2 water molecules get cancelled and 2 water molecules left here. So then can you write the overall reaction? So the overall reaction is 2H2 and O2 because the OH minus get cancelled now. 2H2 plus O2 gives here out of 4 water molecules, 2 water molecules get cancelled. So 2 water molecules left. So 2H2 plus O2 gives 2H2O. This is the overall reaction takes place in the hydrogen oxygen fuel cell. So in a hydrogen oxygen fuel cell, we send hydrogen and oxygen gases. These two gases are subjected to combustion. A huge amount of heat energy will be released. When hydrogen and oxygen gases are burnt, when they are subjected to combustion, huge amount of heat energy will be released. That heat energy is converted into electrical energy. That is a fuel cell. Now, here, what is the final product formed during this process? The final product is water, no? This water is pure water. This water is used by astronauts, those who are going into the space. Do you know one thing? The astronauts who are going into the space, they don't carry water bottles from the earth. They get the water from the fuel cell itself. And during fuel cell reaction, some water will be released, that is a pure water. This water is stored and used by the astronauts. Okay, right. That means what you can understand from here, during hydrogen oxygen fuel cell or during fuel cells, when they are subjected to combustion, what are the byproducts? What are the products formed? Water, no? Water is not at all harmful. So that's why I told you in the beginning, here no carbon dioxide, no carbon monoxide are released. So fuel cells are environmental friendly. So here only water will be released in the atmosphere. Okay, these are very much helpful, but only problem is here platinum and palladium catalysts are used. Those catalysts are costly. Okay, that's why fuel cells are more cost. So we cannot use in all the vehicles and all nowadays, but research is going on. In future we can see cheap and best fuel cells. Then we can see like electric cars, electric bikes, electric buses. In future we can also see fuel cell cars, fuel cell bikes, fuel cell vehicles. Okay. Next, water vapors produced during the process were condensed. Condensed means cooled and added to the drinking water supply for the astronauts. Fuel cells are pollution free. They do not give any pollution to the environment. Right? Here there is a small formula. Efficiency of the fuel. Efficiency of fuel. So there is a formula for this, and that is equal to useful work done by heat of combustion into 100. You can note down this formula. Efficiency of fuel. You can find efficiency of petrol, efficiency of diesel, efficiency of kerosene. Any fuel you take, its efficiency can be calculated by using this formula. So work done by heat of combustion. So see the formula, is equal to efficiency of fuel is equal to delta G naught, that is change in Gibbs free energy, standard change in Gibbs free energy by heat of combustion, standard change in enthalpy, change in Gibbs energy by change in enthalpy into 100. So if you know delta G value, delta G naught value, delta H naught value, you can find efficiency of the fuel. But in the previous classes, we discussed that delta G naught is nothing but minus NF E naught. Remember this formula, delta G naught is equal to minus NF E naught. This is an important formula we have already discussed in our previous classes. And by delta H naught into 100. So just remember this formula, and later in our discussion during objective questions and all, if you get, we will again try to recall this formula, right? Here few objective questions are given based on fuel cells. You try to answer. Which of the following cells can convert chemical energy of hydrogen and oxygen directly into electrical energy? Generally, chemical energy or combustion energy is converted into electrical energy by which fuel cells. So our present context is fuel cells. Next, hydrogen oxygen fuel cell is primary cell or secondary cell or both primary and secondary, or cannot be predicted. In last class, yesterday's class, we discussed about primary, secondary cells. Primary cells means which cannot be recharged. Once they are dead, we will throw it out. But secondary cells are rechargeable. Like the cells present in our mobile phones, they can be recharged again and again. Similar to that, the fuel cells also, secondary cells, they can be recharged again and again. The thermodynamics efficiency of fuel cell is given by. So just we have seen one formula. Okay, what is this formula? Fuel cell efficiency, or fuel cell efficiency is equal to NF E naught by delta H, delta H. But here no formula is given. NF E naught by delta H. That's option C. NF E naught. But here NFE is given. Okay, no problem. Among the given options, the option C is the proper one. Okay, next come to last topic, corrosion. Corrosion is a very big problem industrially and worldwide. Every year, crores of rupees are wasted, and a huge amount of money is wasted due to corrosion. You know what is corrosion? Okay, due to corrosion, the metals will be damaged very badly. For example, here there is a definition of corrosion. Corrosion is defined as the deterioration. Deterioration means damage. Okay, of a substance because of its reaction with the environment due to corrosion. Metals have a tendency to go back to their combined state. You no need to worry about this last statement. You can write up to this point. Okay, you write up to here. What is corrosion? Corrosion is defined as the deterioration of a substance. Okay, because of the reaction with the environment. Do you know how iron undergo corrosion? How iron undergo corrosion? When iron objects kept
It
outside,
reacts with its
it reacts with
air.
it reacts with air and water vapor, right? When iron objects kept outside, it reacts with water and air, undergo corrosion. Some electrochemical electrochemical reaction takes place. So that we are going to discuss about mechanism of corrosion briefly here. For example, rusting of iron undergo rusting, tarnishing of silver. Silver objects become black. When silver objects reacts with sulfur in the atmosphere, a layer of silver sulfide is formed over the jewelry of silver. So the silver jewelry becomes tarnishing, means tarnished means become black. Black coating will be formed, right? Next, development of green coating on the surface of copper. Some copper objects can be seen some green coating over the surface of copper. This is also due to corrosion of copper. That's it. That's nothing but copper carbonate. You can note down all these points. These are the points taken from your textbook itself, and but some important selected points. Now let's discuss briefly about mechanism of iron corrosion. How iron undergo corrosion? Its a mechanism is the process of corrosion we are going to discuss, and this process also includes some chemical reactions, and you no need to worry about these chemical reactions, but better if you can learn the chemical reactions also. See the first point, it is an essential electrochemical phenomenon. Electrochemical phenomenon. Which one? Corrosion is an electrochemical phenomenon. Electrochemical phenomena means in all electrochemical process, we have three important components. What are they? Anode, cathode, and electrolyte. So similarly, corrosion also an electrochemical process. That means during corrosion, anode, cathode, and electrolyte will be there. So now we'll see what are anodes and cathodes and electrolyte during the corrosion of iron. At a particular spot on an object made of iron, oxidation takes place, and that spot behaves as an anode. That means when you keep iron, a new iron object outside, you have bought one iron nail, new iron nail. It's very shiny, no? If you keep that iron nail outside of your home, then on one spot of that iron nail, oxidation takes place. What is oxidation? Oxidation is nothing but loss of electrons. See here, this is some iron object. So at this space, anodic site, oxidation takes place, and loss of electrons. So electrons will be lost. Fe gives Fe plus 2, 2 electrons. So these electrons will move from that site to another site. That site is called cathodic site. Getting my point? Here some iron atoms. This is iron. This is completely iron. Okay. On this spot of iron, a huge number of iron atoms will be there. Here some of the iron atoms loses electrons, becomes Fe plus 2. Fe, write down these reactions. Fe loses electrons, becomes Fe plus 2. Whatever this is called a loss of electron, no, that's called oxidation. These electrons move from this spot to another spot, okay, to another place. That place or that spot acts as cathode. That is cathodic spot. There, see here, there, it combines with water and oxygen, okay, from the atmosphere. Water vapor and oxygen from the atmosphere. See here, O2 plus 4H plus. H plus means from water, H plus and OH means from water, and plus 4 electrons. From where these electrons we got? We'll get these electrons from this anodic process. So electrons are traveling from this spot to this spot, no? Those electrons. So here gaining of electrons, O2 plus OH plus electrons. This is gaining of electrons. That means here reduction is taking place. So due to this process, water molecule will be formed. So these are the two reactions taking place at different spots on iron during corrosion. Electrons released at anodic spot move through the metal and go to another spot on the metal, reduce oxygen in the presence of H plus. See, whatever we discussed now here. So electrons released at anodic spot go to another spot on the metal, reduces oxygen in the presence of H plus, and okay. So this process is called reduction. One second. The spot behaves as cathode. This spot behaves as cathode. That's all, very simple. This is the mechanism of corrosion of iron. So this is the cathodic reaction. Just already we have discussed here, the same reaction. So during this process, the electrode potential value, the total electrode potential 1.23 volts. That's okay. No need to worry about that value. Now finally, the overall reaction. If you can write both the reactions, you can find overall reaction. So this reaction and this reaction, you write one by one and you can find overall reaction. So that is 2Fe plus O2 plus 4H plus gives 2Fe plus 2 plus 2H2O, right? And but here you see, you make a small change here. You can see my cursor now, the cursor point. Here Fe is given now, you write it as a 2Fe. Write it as 2Fe gives 2Fe plus 2 plus 4E minus. 4E minus means you multiply with 2. 2, here 2 2s are 4. Then you write this reaction just below that. Then you cancel the 4 electrons and 4 electrons, and remaining parts, whatever the cancellation can be done. Then finally you get the overall reaction like this. 2Fe plus O2 plus 4H plus gives 2Fe plus 2 plus 2H2O. And cell potential is 1.67 volts electrode potential. And the spot behaves as cathode. This spot behaves as cathode. That's all. Very simple process. Here Fe plus 2 ions, whatever produced in the first reaction, see here, Fe plus 2 ions are produced, no? These Fe plus 2 ions oxidized by atmospheric oxygen, and finally they are converted to hydrated ferric oxide. Hydrated ferric oxide. These Fe plus 2 ions again combined with oxygen, finally converted to hydrated ferric oxide. Fe2O3 XH2O. This is called rust, right? This is a rusting of iron, corrosion of iron, and with the further production of H plus ions. What is the formula for rust? Fe2O3 XH2O. Rust is also called as hydrated ferric oxide, right? That's all, my dear students. It's a very simple concept. And finally, the prevention of corrosion. This is an important part, but very simple. How to prevent corrosion? This might you might have studied in lower classes also, like 10th class. How to prevent corrosion? To prevent corrosion, what we can do? We can cover the surface of metal with paint or some other chemicals or oil. When you paint the metal,
Galvanizing.
galvanizing, okay. When you cover the surface of the metal with paint or oil something, the surface of the metal will not be exposed to atmospheric oxygen and water. When the surface of the metal is not exposed to directly exposed to atmosphere, then it will be protected from the corrosion, right? So simply covering the surface of metal with paint or some other chemicals like bisphenol. You might have seen this bisphenol very frequently whenever some iron objects are there, they are painted with some brown colored paint first. That brown color paint is some chemicals. So bisphenol like, they protect the surface of the metal from undergoing corrosion. The cover To cover the surface by other metals like tin, zinc, that are inert or reactive to save the object. We can cover the metal surface with tin or zinc. Particularly if you cover the metal with zinc, it is called galvanizing. As you said, galvanizing means what? Covering the metal, other metal with the zinc. That is called zinc coating. That zinc coating is called galvanizing. So next, to provide a sacrificial electrode of another metal like magnesium, zinc, etc., which corrodes itself but saves the other object. Sacrificial means sacrifice. One metal sacrifice for other metal. See, for example, if you take iron and zinc, zinc is more reactive than iron. Zinc is more reactive than iron, or magnesium is more reactive than iron. So when iron is coated with magnesium or zinc, this magnesium or zinc undergo electrolytic process, but they save, they protect iron from undergoing corrosion. That is called sacrifice. See, two friends are there, you and your friend. Your friend is sacrificing something for you. Okay, he is undergoing some struggle just to help you. That's called sacrifice. So the best example of sacrifice is your parents. The parents are sacrificing everything. Not only your parents, every parent, universally, every parent sacrifice everything for the sake of their kids, their children, isn't it? So that means they protect us from undergoing any hardship, but they themselves undergo many hardships. They want to take risk, any risk, for the sake of their children. So similarly, the highly active metals like zinc and magnesium, they protect the other metals from undergoing corrosion, right? That's all, my dear students. And a few questions are given here. See, corrosion is physical change, neutralization, electrochemical change, or thermochemical change. So corrosion is an electrochemical change. So it includes anode, cathode, and electrolyte. Next, metal with high concentration of oxygen on its surface acts as, wherever oxygen is present, oxygen and water vapors, that part is act as anode, cathode, or electrolyte insulator. That is cathodic part, no? Wherever oxygen present, when oxygen undergoes a reduction, that part is cathodic part. Next, zinc corrodes in. This is some important point, is not covered in our discussion. 2m alkaline solution, 2m acidic solution, and 2m, m means molarity, 2m neutral salt solution, all the above, 2m acidic solution, right? And this is the end of the class. In next class, we'll discuss some important previous year questions. But it may take long time to discuss all the questions in a single class. So it may take 2 or 3 classes. Or otherwise, what I am thinking is, I would like to record the video of previous year questions and post in the YouTube channel. so that you can watch that video later and you can practice the questions. If possible, I will post all the questions, that PDF of the thing whatever I am discussing, in our WhatsApp group. You can also download the PDF and you can also practice yourself. That I am going to cover only previous year questions only. Okay, we cannot discuss exercise questions and all here, because we are not following any particular material. Okay, dear students, I hope you understood today's concepts. That two concepts we discussed today: fuel cells and corrosion. Okay, we'll meet in the next class.